Welcome back to another maths video. In this video, we're going to be looking at equation of a circle and tangents to a circle. The equation of a circle is x minus a whole squared plus y minus b whole squared is equal to r squared. And this is something you need to know. A and b are the coordinates of the centre of the circle, and x and y are the coordinates of a point on the circle, like this. But what matters is how we come to this equation. If you couldn't care less about why the equation is what it is, go to this timestamp shown here to go to some examples. Otherwise, continue watching. So, how do we get this equation of a circle? Well, let's say we have a circle centered at point A, B, and let's give it a radius r. Let's also label a point on the circle and call its coordinates x, y. Now, we've drawn a right angled triangle that stretches from our center to our point x, y. So we know that this point on the x-axis is the point x, right, from this point, because it has an x coordinate of x. Similarly, we know that this point on the x-axis is the point A, again from this point here. So, to find the length of this line here, we need to subtract a from x, right? Because if I have a line of length 10 centimeters and another line of length 6 centimeters, to find this line here, I'll need to do 10 minus 6, which is 4. So similarly, this line is going to be x minus a, so that's x minus a. Similarly, this point on the y-axis is going to be the point y from this point here, and this point on the y-axis is going to be the point b. So, like we did last time, we can subtract b from y, giving us this vertical length, which is y minus b. Now, we know that the radius of our circle is r, and because this longer side of the right angled triangle stretches from the origin to our point, we know that this side must also be r. So, taking all three sides into consideration, can you see that we can use the Pythagoras theorem to find an equation involving our point x, y? Remember, Pythagoras theorem states that the two shorter sides squared and added together, so a squared plus b squared, equals the longer side squared, so that's c squared. In the same way, we can square the two shorter sides to equal the square of our longer side. So that's going to be x minus a squared plus y minus b squared is equal to r squared. And just like that, we've got our equation. Pretty darn simple, eh? Now let's have a look at an example question. A question says, the point 6, 8 lies on a circle centered at the origin. Find the radius of the circle. So, we can use our equation to do this. Just slap the numbers in. So our x coordinate is 6, our y coordinate is 8, and as our circle is centered in the origin, both a and b are 0. This gives us 6 squared plus 8 squared is equal to r squared. 6 squared plus 8 squared is 36 plus 64, which is 100. So 100 equals r squared. Now we can square root both sides to get r on its own. So the square root of 100 is 10. So r is 10. And just like that, we've got our radius. Now let's look at tangents to a circle. A tangent in this case is a line that touches a circle at right angles to the radius. So it would be something like this orange line here. You might be asked a question or two about the tangent, so let's look at those. Here we've got a circle with the equation x squared plus y squared equals 25. A tangent touches the circle at the point minus 4, 3, and we're being asked to find the equation of the tangent. So immediately, by looking at the equation of the circle, we know two things. Firstly, the centre of the circle has to be at the origin, because a and b aren't included in the equation, so they must be 0. The second thing we know is that the radius of the circle must be 5, because 25 is r squared, and the square root of 25 is 5. Now we can draw a line from the centre of the circle to the point where the tangent touches the circle, and because this is also a radius, this line here, it must have length 5 as well. But how does this help find the equation of the tangent? Well, just... So, do you remember how tangents touch the radius at right angles? Well, this fact allows us to find the gradient of the tangent, considering we know the gradient of the radius first. And this is because the gradient of any two lines that are perpendicular, aka at right angles, multiply to give -1. So if a gradient of, say, a line was 3, and the gradient of another line was -1/3, I would know that these two are perpendicular because they multiply to give me -1. Now this is an incredibly important point, and you can use it in other places too, for example proofs. So back to the question. The gradient of the radius would be y/x. So that's -3/4, right? Because we're going down 3 and to the right 4. So the gradient of the radius is -3/4. Now the two lines that are perpendicular, the radius and the tangent, have to have gradients that multiply to give -1. And because we've already found the gradient of the radius, -3/4, we can use this fact to find the gradient of the tangent. So -3/4 times something, so the something is going to be the gradient of the tangent, is equal to -1. Now we could just divide -1 by -3/4, but that's a bit long. So let me show you a simpler way. So all we have to do is take the gradient of the radius, so -3/4, and then flip the fraction, so it becomes 4/-3. This is called taking the reciprocal. Next, we take the sign, so that's a minus here, and reverse it, so it becomes a plus. So from that, we get 4/3. And this whole process is called taking the negative reciprocal, because first we took the reciprocal, then we switched to the negative. And there we have it. The gradient of our tangent is 4/3. So we know that the equation of our tangent is going to be y is equal to 4/3x plus c. Now all we need to do is find c, the y-intercept, and we're done. To find c, we need to take a point that is part of this tangent. Well, there's only one point that belongs to the tangent on this diagram, and that's the point -4, 3. So what we can do is slap this bad boy into the equation by substituting, and then we can solve for c using this. So we can multiply 4/3 by -4 to get 3 is equal to -16/3 plus c. Next, to get c on its own, we can add -16/3 to both sides. So that will give us 3 -16/3 is equal to c. Now we need to simplify this down further because, it can be simplified down. So we get 9/3, which is the same as 3. Oops, let me do that again. 9/3 minus 16/3 is equal to c. Now 9 minus 16 is -7. So c is going to be -7/3. And now we've got all the parts of our equation for the tangent. So we can just put this in, and we get for our final equation of the tangent, y is equal to 4/3x minus 7/3. And that, for God's sake, over 3. And that is our answer to the question. Boom! We are done. So before I go, just wanted to say, please do check out The Motivationpreneur on Instagram. That's The Motivationpreneur on Instagram. They post really motivational stuff, and I'd highly recommend checking them out. So, thank you for watching another brilliant video by me. If you like the video, please do like, subscribe, and share with your friends. I'll see you in the next one.